Today let's talk one problem in Blender 75, one hard problem. The Leetcode 23 merge key sorted list. That means there are several sorted linked nodes. For every node, it's the structure, integer value, the class name. The class name is ListNode, and one of the component is integer value, and there is another list node. Next, we have several sorted list nodes. For example, there is 1, 5, 8, 12. So the next node of 1 is 5, next is 8, and next is 12. We have another 2, 8, 11, or 3, 6, 10. So we need to merge them into one list. That means x0, x1, x2, x3. This is we need to merge them into one sorted linked list node. This is the description about the problem. Let's talk about solution. In this part, for a specific solution, we will know. First of all, we can check the. We can get the first for every element in this vector. That means for example, there are key sorted linked nodes. This is a vector. Every node is a sorted linked nodes. So we can get the first elements for every. We can get the first element in this vector. We can get the smallest value, and this will be the first value. For example, take this example. So the first will be the first value, and we update the first value into the next one. That means this is the next one. So for among all this value, that means 3, 2, and 5, we will know the second is the 2 is the second smallest value. So this will be the second value, and this will be 3. And in the next part, the list will be this value. I mean 5, 6, and 8. So the next thing will be 5. This is one of the solution. But the time complexity will be very high. It means, for example, every time we choose the smallest value, we need to travel the k elements. And in addition, we need to calculate this n times. N will be amount or a node. So the time complexity will be k plus k multiply n. Okay, this will be the time complexity. This is the first solution. For the second solution, we can copy it. We can copy the example 5, 8, 12, 12, 12. Okay, next will be 8 and 11, 3, 6, 10. Okay, in the next part, we can use another method to optimize. Yes, this video will show more optimization method for this problem. We can use a priority to store these elements. This means the default priority queen will be a max priority queen. That means the top value of the priority queen will be the largest value in this queue. But for this problem, we need to the mean priority queen. So the top value should be the -1. We can so the first step we can insert or add all first elements into the priority queen for the every element in this vector. Okay, that will be 1, 2, 3. I mean this value. This is the first step. For the next step, we can choose the smallest value in this priority queen. This will be the top value of this priority queen, and will be the first node of the result. So this will be result. This value will be 1. Yeah, this value. Okay, next we need to add another element into this priority queen. We need to add 1 next. It will be 5. Okay, that means we need to add. Actually, we can make it at the this will be the second step. For the third step, we need to this one we need to add the next node of 1 into the priority queen. That this value will be 5. Yeah, this is how we made it work. Next, we can return the first step. That means we can choose the minimum value from the priority queen another time. This is how this problem works. That means we every time the first thing is we can choose we can first thing. Actually we shouldn't return the first step. That means we need to for the third time we need to return the second step. That means we can have a loop, do the second step and third step. That means get minimum value. That this is 1. The second step will be the get the minimum value of the Q queen. This will be the next point. This will be for 1, 2, 3. This will be the next point of the result. In addition, we can add the next one into the priority queen. So let's take this as an example. We will get this kind of result. For the first step, the queen, that means the priority queen, will have 1, 2, and 3. So we can have the this will be the first value. So the first will be 1, and we can update it into 5. So this is first step. Second step will be the 2 will be 2, 5. Second will be the next one, so it will be 7, and update the 2 with 8. So it will be for the third step. It will be 3, 5, and 8. Will be the next will be 3. So we can update the next point of 2 into 3. So and update 3 to 6. And for the next step 4, this value will be 4, 5, 6, 8, and the minimum value is 5. So update it to 5, and update 5 to 8. This is how it works. So in this method, the time complexity should be every time we update the we add a value into priority queen, the time complexity should be log n. Log k, because the length of it is k. There are k sorted linked nodes, so the time complexity will be k, and we need to do this narrow n times, there are n nodes. There are totally n nodes, so the time complexity will be n multiply log k. Next part, time complexity. For next part, the time next part should be the complexity. We should talk about time complexity. For the method 1, it will be k multiply n. For the second method, it will be n multiply log k. Okay, this is how we solve this problem. For the space complexity, for the first method, we don't need extra space. Yeah, so the space complexity should be O(n). For the second, it will be n multiply. For the priority queue, the space complexity of priority queue should be n log n, k log k. So it will be k log k. This will be the space complexity. Actually, the second method just use the priority queue to solve this problem, which can reduce the consuming time. Yeah. If you have any confusion, welcome to submit a comment. Recently, I will talk about more blend 75 problem. Thanks for your watching.